What's poppin', dogs? Mr. Allen here with a fun little challenge problem of finding the perimeter of triangle ABC. Now, all we have is the measure of angle A is 35 degrees, the measure of angle C is 50 degrees, and this length right here, BC, is 12 feet. This isn't even a right triangle because these two angles add to 85 degrees, which leaves 95 degrees for this one. So I can't even use like right triangle trig yet. All right, now if you want to try this thing, hit pause because I'm going to start solving it here in a moment. All right, let's get after it. Okay, so I can't use right triangle trigonometry as it sits, okay? And I'm going to assume that you haven't done non-right triangle trigonometry yet. So we're going to solve this with right triangle trig, but we got to do some things first. Now, something you can do, it might seem illegal, but I'm going to grab a straight edge over here. You can drop an altitude in this triangle here, okay, straight down from angle B. So I can drop this guy, boom, breaking this triangle up into two different triangles. Now, the key legal aspect here is that when I draw this altitude and I make this right angle, all of my math is based off of that, okay? Meaning, I can't assume other things like, I don't know if this side is split in two perfectly or in thirds or whatever, right? I don't know that. I don't know how this angle here has been split yet. I could figure it out, but I can't be like, oh, it's just cut in half because I drew it. No, we can't assume those things, all right? There is other stuff that we can do, but we have to play off of the fact that this is a right angle. That's all I've done. I've drawn a line segment in my triangle and made that perpendicular, made that a right angle, okay? So now let's see what we can do here. Well, my goal in finding the perimeter is getting all of my sides. And I might have to do a little extra math beyond that. We'll see. I can figure out this portion right here from the 50 degrees and this 12 feet, can't I? Right? So let's do that. I'll call this X right here. So this is going to be X. Now, this from angle 50 right here, this is my adjacent side. This is my hypotenuse, right? So that's going to use cosine for this one. So I'll have cosine of 50 degrees equals my adjacent, which is X, over my hypotenuse, which is 12. This one's a pretty easy one to solve. I can just multiply by 12 on each side. And I'm going to type that into my calculator. Make sure you are in degree mode before you get math in here. So if I hit mode, down here I'm in degree mode. So I'm good to go, okay? If you're in your trig unit, which you probably are right now, if you're doing a more of a challenging problem, then you're probably already in degree mode. But I always just double check. Or if you come up with some weird answer, you're probably in radian mode, which has its place in math, just not right now. So I'm going to do 12 times the cosine of 50. And I get 7 point, so let's see here, X equals 7.713 ... Okay, so I always write it all out in a problem like this because I might use these values again to calculate another length. And yo-ro, you only round once. I'm going to wait till the very end to round my final answer. I'm going to work with the value that's in my calculator, the 7.71345, blah, 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 if I need it. Okay, so I'm going to work with that one in there. I'll be able to arrow up and get values and things like that. You can see some old ones in there that I've had. All right, next part. So I've got this side here, but now I'm kind of stuck because I can't get anything from this guy or that guy that's a part of like this right triangle over here. Perhaps if I figured out what this length was, which I'll do, let's say in green, I'll call it Y. If I solve for that length, then I can use that in a trig situation to get these lengths, okay? Now, you have a couple options here of how you want to solve for this length. I could use Pythag to solve, or I could set up another trig function. Since we're getting triggy with it already, I'm going to show you the trig, and I'm also show you that the Pythag would also work. So this right here, with reference to my 50 degrees, is my opposite side. So that means I'm going to use sine opposite hypotenuse, opposite over hypotenuse. It's going to be actually the same setup here, sine of 50, just I'm using sine this time, of y over 12. Multiply by 12, and that's what I'm going to type in to get y. So we'll do 12 sine of 50. I'll close my print. Almost missed one there. Let's do that again. 12 times sine of 50. There we go. Got the 0 this time. So we get 9.192. Okay. So y equals 9.192. I didn't round that up because I'm not rounding here, right? You only round once. Okay. So that would have rounded up to a 3 because there's a 5 after it. I'm not rounding yet. I'm leaving this so I know what values to grab in my calculator when I continue mathing. Okay. So There we go. We've got that value. Now check this out. If I wanted to do Pythag, I could have had 12 squared minus this guy's squared and the square root of that. Check it out. 12 squared minus, and then I can arrow up and use my previously calculated value squared, and then square root it, and I get the 9.195, so on and so forth. Almost only one very last number there is slightly off because the calculator does round, just using more decimals. All right, so however you want to do it, whether it's with trig or with Pythag, you'll get the same answer. Okay, so now we have this value, which should allow me to get other values as well. How about I get this guy right here? We'll call this one Z. All right, so that's this whole length right here. Oops, to here. Okay, I didn't plan for my teacher bracket there very well. So opposite, this is adjacent. That sounds like I'm going to use tangent, right? So we'll have tangent of 35 equals my opposite, which is the 9.192 and change, over Z, which I don't know. So unfortunately, this is a little bit trickier to solve algebraically. I got to multiply by Z on both sides. And now I have Z times the tangent of 35 equals that 9.192 and change. And that'll divide by the tangent of 35. So an extra step. It happens. Some people memorize these things and know, oh, I'm just going to divide by that, or I'm going to get this. I don't like to. I like to work it out each time just so I'm setting up the problem and I'm working on my algebra skills and I know how to solve these things so that I don't just memorize it for this one. I can apply that concept to any situation, okay? So now I'm going to have Z equals, and let's get that thing. So we're going to do the 9.192, which I actually have right now, right? I can use this one or I can use the one we did with the trig, right? I can just bring that down, divided by tangent of 35. Tangent 35. Hit enter. And that's what Z is going to be. It's 13.128 and change. Okay. So we've got our X, we've got our Y, we've got our Z. There's one more that I need up here. I should have started earlier in the alphabet, but we'll go with, how about W right now? W, X, Y, Z. Should have started with W. Man, what was I thinking, bro? All right. So how am I going to solve for W? I'm going to probably do it up here because I'm running low on space. Well, I know I can either use Pythag with these two values. I could do trig with these two values, right? This one that I calculated before, or even this one, and then solve for W. Let's just do the Pythag route, okay? Because otherwise, I mean, I've gotten tricky with it enough here. Let's hit it with some Pythag, shall we? And then we'll show both. We'll show both. We're going to show both. Okay, I'm going to do trig first. Then we'll do Pythag. All right. Like I'm just changing my mind randomly. Okay, so with respect to the 35 here, this is my opposite. So and I want my hypotenuse, so we're using sine of 35 equals my opposite, which is 9.192 and change over my hypotenuse. So the algebra is going to work out like we just had in the last one, where I got to multiply by W. And then I'm going to have W times the sine of 35 equals 9.192 and change. Divide by the sine of 35 this time. Just enough room to make it happen. And we're going to get W equals. So we got the 9. There we go, that guy. Boom. Divided by sine of 35. Looks good. Hit enter. Boom. We get 16.026 and change. Okay. And I'm going to show you guys now, like I said, with Pythag. It's a little easier to do Pythag without work here. I wanted to show the work here with the trig. Because if you're in trig mode, you're probably just going to keep on cruising with it. In my geometry and construction class, we hit a lot of things with Pythag, so it comes a little more naturally to just be like, oh, I got two sides, let me get the third with Pythag. Well, if I take that 9.19, I square it, and I add this 13 squared, square it, and then I square root that, which I'm doing raising to the 0.5. That's the equivalent of square rooting. Check it out. Second x squared. If I put this guy into a square root, I get the same thing, right? Raising to the 0.5 or raising to the 1/2, rational exponents. Quick way to do a square root without having to go through the menu options. So we get 16.026 either way, right? Pythag it, trig it, you're going to get the same answer. A couple different ways to do this. Now we need a perimeter, okay? So we got to be careful. 12 plus, I need my x, which was the 7.713. So I'm going to go up, and I'm going to get that guy, because YOLO, you only round once. You could probably get away without rounding here, but I'm going to do it because I want to, okay? Got that one, plus, then we got, so we did this guy. Now I need the, do I need this one? No, that's on the inside, so don't accidentally add that. How about Z? We need the Z one, right? That's the 13.128, there it is. And then I'm also going to add what I got for W, which is the 16.0266, blah, blah, blah. Hit enter again, boom. We've got our final answer here. Just in time, we've got 48.868. Now's the time that we round. 87 feet. We'll do nearest hundredth. That is my perimeter of this bad boy right here. Had we rounded these values along the way, it can cause issues, okay? If I round this to 7.7 and then I calculate it with, this one's going to be slightly off. And then if I round this one, now this one's going to be slightly off when I use it to calculate this one, and so on and so forth, and those errors compound, hence the yo-ro, you only round once. And it's super helpful in these trig situations, and honestly, it's kind of nice because you can just use the arrows on this thing to get your values. You don't have to be typing them in. I just write down the first 3 digits of the decimal so that I can recognize it in there quickly if any of the numbers get kind of close, numerically speaking. All right, that's it for that one. Hopefully you guys held on to that, and if you did it on your own, very impressed to get 48.87 feet. Well done, and have a great day, dogs. See you later.